Hi, everyone. Thank you so much for joining our webinar. My name is Sonia Mankin, and you'll see some other folks here on this call. So my name is Sonia Mankin. I'm a solutions architect here at Databricks. We're also joined by Denny Lee, who's on our, and feel free to correct me if I'm wrong here, Denny, who's on our developer relations team. And then Tyler Croy, who is part of the open source Delta Rust community, who's helped a lot with this specific project. And then our esteemed presenters, we have Satya Mandavilli, who is a solutions architect at S&P Global Commodity Insights, and Madhukar Nathala, who is a director also at S&P Global Commodity Insights. And they're going to talk to you today about some of the solutions that they've implemented using Delta Rust. So with that, I'll pass it over to Madhu and Satya to kick us off.
Cool. Thank you so much, Sonia. Hope everyone can see me, hear me. Okay. Good morning, good afternoon, good evening, wherever you are. Uh, my name is Satya, as Sonia already gave them my introduction. So I'm part of the core platform team. My main focus is keeping our platform simple for our users. To do that, I work on creating different architecture solutions and common capabilities for our users. Along with me, we have Madhu. Madhu, do you want to
Hi
go?
everyone, this is Madhukar. I work as Associate Director at S&P Global Commodity Insights, and I lead teams focusing on the design and development of reusable and common components, which ensures that our software architecture is both robust and adaptable. So with that, I'm really excited to look forward along with you. So yeah, that's it.
Cool. Yeah, so as Madhu said, we are really excited to share our journey. If you decipher the title, The Rusty Waters, Elevating the Lakehouses Beyond Spark, there is a spark and there is a lake house, there is rust. What are we going to talk about? I love metaphors. Let's see if I can explain this in a metaphor. Here is our lake view, and then there is a house, and there is a sunset. And let's assume my kids are playing in the backyard there with some fireworks. And as they are playing with the fireworks, some of the sparks from the fireworks started coming inside the house. Luckily, we have some rusty waters in hand, which saved our house with burning from the spark. I don't know how much you're able to decipher from this. Let's see from the remaining content if we're able to explain it in better way. Otherwise, let's come back to the same story in the last slide. Here is the quick agenda. We'll start with the context of our work and then followed by a problem statement we have faced. And then we'll dig deep into a proposed solution and then the benefits and challenges we have encountered. And finally, we'll have a Q&A as well. So before digging deeper, let me take a moment to introduce who we are and what we stand for. We are from S&P Global Commodity Insights. We provide a comprehensive view of global energy and commodity markets, ranging from different sectors like crude oil, agriculture, coal, power, and quite a lot of other commodities as well. So basically, we provide different solutions with market data, price assessment, real-time insights, advanced analytics, AI tools, all for our clients depending on when and how they need it, so that they have the insights they need to succeed. So this is about our platform. More than calling it as a platform, we say it as an ecosystem called Advanced Data Workbench, aka ADW. ADW is a big platform, a big umbrella of different tools and technologies used by different data citizens, as you can see, for their day-to-day work. And there are different applications or machines or processes interacting with it, right from the data exploration, cleaning, enrichment, modeling, generation of insights. And we do have different delivery channels as well. So there are different data ingestion systems like batch jobs, streaming jobs, uh, and there will be analysts who are going to gather some insights. And there will be some ontologists who are going to blend the data whenever any new data has arrived. And then there will be data engineers who will be cleaning up, doing the enrichment, and there will be modeling teams who are going to create some models and run inferences. And with all of this, there is an orchestration layer to handle all the different tasks. And behind the scenes, we as a platform engineers present for our users to provide them with all the capabilities they need, right from the logging, monitoring, alerting. And also we do have certain controls in place, like having compliance checks, governance checks, cost control checks, anomaly checks. And with this, once your data is ready to be shipped, then we have different delivery channels, right from the UI, API, and different BA tools and cloud delivery channels. And one of our key delivery offering last week was our AI ready data solution, where we are the first ones to host our solution in Microsoft Copilot as a subscribed connector. And with this, these many things in place, our Lakehouse platform is a central stage for us. And as you can see, Delta Lake is our golden source. Let's dig deeper into the different scale of operations. As you see, these are specifically for our Lakehouse platform. We have at least 3 petabytes of processed data sitting there, and at least 1200 or 1300 active users using this data through different jobs and different tables we have onboarded, right from the different stages, like I mentioned, collection, processing, modeling, for all different use cases. So as the volume is growing, and then there is a critical need for having efficient processing solutions, as well as to have a better insights from these many data sets. And with great power comes great responsibility. We had a clear goal of having a dedicated enterprise grade wide Lakehouse platform for our users. And as you see, we had different set of users, different data personas. We interact with them on a daily basis, and we collaborate with them to handle their tackle the data challenges they face. And also we have a clear requirement to giving the flexibility for our users so that they can onboard you choose their tools and technologies to deliver more value for their requirement. So to have these many challenges, we have seen the big problem here, where we come into the problem statement. Before when we designed this platform as a whole, we have kept like it's all big data in mind. And then as even our users were also in the same opinion, they are think that we need a Spark for everything. Spark is a good, powerful tool, but it may not be the best fit for each and every workflow. Why do you need an AK-47 just to kill a mosquito? So this is an example that I usually take where people are dealing with smaller workloads. For example, why do you, there was some instance, maybe one application team, they were running just a few megabytes of data just to process a CSV and convert into Delta Lake. And they needed a driver, a worker, and then they have enabled auto scaling as well, just to convert that CSV to Delta. So this is just an example. And again, with the cost as well, as we can see with running the Spark jobs, cost can be high sometimes, and maybe more than the ROI you receive from that particular job, it may be much smaller than the cost of running your job. And wait time as well. So if you see, we have a lot of cluster policies, and then there may be other wheel packages that has dependencies. Just to spin up a particular Spark cluster, you might be needing at least 10 minutes. Sometimes your data or market moving data updates might be of no value if it is more than 10 minutes. And there is a knowledge gap as well. As you can see, we have different personas in the platform, and not everyone may be well versed with the Spark, or maybe they may not be having idea about having different configurations we may need to just to interact with Delta. And with these many complexities in mind, we had a clear problem to tackle these as a platform. And we have a clear requirement as well to handle all kind of workloads as well. With that, I'm handing over to Madhu to dig deeper on this problem and requirements we have.
Cool. Thank you so much, Satya, for setting up the context, like what we really do around AW and helping us our diverse needs of our users, and how AW is kind of really look towards identifying the problem statement and making sure that kind of readily, it's available to every user by implementing end-to-end capabilities and automations around it as well, right? I mean, as already Satya stated, the problem statement. I mean, I would like to extend the little around the different set of requirements as well. Right, as Satya, I mean, as we mentioned, right? I mean, AW as a platform, we seen problems which there is a clear need of moving away from Spark and big data mindset, right? And now I would like to talk around the requirement like which are needed by our users to support different set of use cases as well, right? So with that, I would like to start. So the simpler and complex workflows, right? I mean, we have a diverse of users and their needs, and ranging from simple workflows that are requiring minimal processing to complex workflows that involve intricate data transformations as well. It's really essential to platform to support so all these kind of workflows to make sure the workflows are working seamlessly. And we have as platform is having different applications hosted into it and different set of users using it, right? So we need to, as a platform, we want it to be flexible to our end users, consumers, right? Bring your own processing tool, bring your own compute engine, right? And onboard into the platform and just get your data transferred, right? As you seen in a picture, like the central part of it is a delta lake. We choose as a platform, we choose that as a our centralized storage solution. So this allows users to set their source and destinations as anything they choose, providing them with the flexibility to work with the various data sources and destinations without being locked into specific framework, right? And so at the same time, like choosing a processing tool set, I mean, so we kind of we wanted to provide a flexibility to our end users to opt their processing tool or switch between processing tools based on the complexity of their data and workflows which they are processing. Right? For example, users may prefer pandas for lightweight data manipulations or Spark for large scale data processing, and or it could be DuckDB like for analytical queries which can be fasterly queried and which is really helpful to build my consumer needs as well, right? So considering all this, like platform always want to be a flexible to ensure the users can select the most appropriate tool for their requirement in the task. And of course, like the compute engines, right? Finally, I mean, the choice of the choice of compute resources is crucial. Users should be able to bring their own compute. So based on the factors such as the complexity, the performance, usage analytics, and cost considerations, right? So whether they need powerful resources for heavy data processing, or it can be converted to, or it can be used as more affordable options for simpler jobs, right? So we want our system to offer a range of choices to meet our consumer needs, right? So this is one of the slide which I got. I mean, slide which I ordered by referring the famous blog on Mother Deck, right? Which says 90% of workloads are 100 MB or less. So which might be a similar situation we are also talking about here, and we seen similar use case in our platform as well, right? So one thing like we need to double check ourselves, right? I mean, basically most of the use cases we never do data processing, big data processing, or we never do big data querying unless there is a need of bulk loads and generating the reports as they need, right? So why do we want to burn your entire lake house with Spark or for a simpler workflows or simpler use cases, right? So is it really important to bandwidth all this infrastructure and cost effectiveness to process simpler workflows? So with that, now imagine the processing Lakehouse data with less infrastructure, more speed, and addressing the challenges what we have discussed, the problem statement like what Satya has also brought it up, right? We kind of utilizing the Delta RS library as a key component for our solution, which I'm really deep dive in upcoming slides. But coming to Delta RS, like it's may we all know, right? I mean, it's a native Rust library designed for Delta Lake, which allows us to efficiently interact with our data storage without overhead of traditional frameworks. And the another significant advantage what we have seen when we are implementing this solution, right? I mean, there is no headache of maintaining the JVM or other resources like that, right? And as we integrating this solution into our existing use cases, like I mean, most of our use end users are data engineers, data analysts, right? So to interact with Delta Lake without Apache Spark, I mean, it's kind of reducing the cost and simplifying of data pipelines through API. Right. So let's see, like, how our Delta R is like make it in action, like how unlocks the doors. Definitely it unlocked a few of our doors for sure, right? I'd like to add little context around like how Delta R is action in action it does, and how it helps querying as well, right? Delta RS uses Apache Arrow, which makes it easily compatible with the other native libraries and tools as well, right? Delta RS scans the records with the Delta tables in the storage and puts them into Apache Arrow record batch, right? So once the records available in a record batch, it we can make it, we can construct them into arrow table, so it can be easily consumed by our downstream libraries or tools. For example, if you see here like DB, Polar, Daft, I have added as an example, so which have a native integration with Arrow, so they can so our consumers can use these tools and can query it using error tables without any serialization or deserialization steps additionally added, right? So with that, and I would like to discuss around one of the hypothetical example which uses medallion architecture here, right? So here, if you see in the diagram, so we have a different stages as a raw data, clean data, enriched data, just like in our Delta technology, bronze, silver, and golden data, right? Which we wanted to be available to our end users, right? So I mean, if you see, like, the data in different stages, like it really doesn't need, each and every stage needs a similar same processing tool or same computation process. And as we see, like here we have a three different processes which are fine tuning the data to make it available to our consumers, right? For example, if you see, like, when on this example, if different teams are working on the same data set, which they are kind of making sure the data is enriched and available to consumers, right? So, for example, uh, data collection teams are using EC2 instance, EC2 as a compute engine, and writing the raw data into Delta, and they are using Polars as a processing tools, right? And same raw data which is consuming by using compute engine as a ECS Fargate, because for applying transformations or processing loads, I may not need a same compute engine as while I'm processing to raw data, right? They are using the ECS Fargate, right, and writing into applying their transformations, manipulations on raw data, and this saving it as a clean data in Delta by using Daft as a processing tool, right? Finally, like, to make it available to consumers, our data scientists or modeling teams, uh, where they're applying the final transformations. And here, like, it's already most of the data is cleaned up. I just kind of applying styling and everything on the data. Definitely I may not require same compute engine, and I can have a flexibility to choose lambda, and I'm using the panda here to do, to make it less data manipulations, and saving data as enriched data in Delta, right? And if you see the processing tools, whatever we use while data processing, right? Polars, Daft, and Pandas. So all are connected internally with Delta RS, right? And coming to our consumer use case, right? I mean, whenever the data available, of course, it's need to be available to end users. Right? I mean, whenever consumers are reading one of the use cases, they are using DuckDB, and of course, DuckDB is kind of internally using Delta RS as well. Okay, so now I would like to talk around the effect. I mean, when we are solutionizing some of the workflows, what we have in our platform, right? So here I would like to talk around like one of the example workflow what we have in our platform, and how it helped us how it helped us in with different perspectives when we choose this as a solution, right? For example, if we say we have one workflow which is processing 100 MB data set, right, on and which is running every hour, right? And before what we have this in we are running this as a notebook and using Spark to write data using Spark to Delta Lake, right? So when we are running this on a Databricks, right, I mean, it's kind of costing us around $52, which includes Databricks and AWS, both computational resources cost, right? And it's kind of taking 6 minutes to resource spin up time, because we all know like to run Spark anywhere, like we need some computational resources, and which also need some libraries and any custom scripts which you need to install, right? So everything needs some resource spin-up time, right? So on average, like when we seen that it's taking almost 6 minutes, right? And the job run time, right? So after the resource pinned up, and when job really starts execution, and to make it available to business process, I mean, be it Spark session, registration, and everything. So on an average, can say it's taking as a 10 minutes, right? So let's see in action like how it helped when we converted this simpler flow, one of the simpler workflow to uh, this, right? So the same workflow we converted into Lambda as a compute engine using Delta RS. Boom, surprising, like it's really a good save for us, like kind of cost. It's costing us $7 per month, right? I mean, bringing it from $52 to $7, it's really it's a lot of cost. I mean, this is with respect to one of the workflow what we kind of demonstrating here, right? And this was spin up time, as we know, like in a Lambda is kind of spin up fast, and on an average it's taking 1.4 seconds to readily available to run my business job. And be it because of resource spin up, or I don't need any JVM missions or clusters need to be spinned up, or no, there are no dependencies, and it's tightly connecting I mean, it's tightly using the Delta RS, which is well-known framework built on Rust, right? So on an average, it's taking 4 minutes, right? I mean, if you could compare the my old before job and after job, like be it cost or data availability, right? I mean, it's really improved a lot, right? I mean, so if you see even consumer perspective, right? I mean, the after stage, right? So earlier it was taking 10 minutes to data available to our my end user or my downstream application, but now it become available in 4 minutes, which is really helped in some of the aspects, right? So with that, I would like to extend the benefits of while we are using the Delta RS in your solution, right? So easy to onboard. Definitely, it was really seen as a significant advantage because of it's a straightforward API allows data engineers to and analysts to quickly familiarize like what how to onboard, how to utilize Delta arrays, and what all available connectors, right? And the other thing is like cost saving. Like definitely we seen in the last slide like how it saved for one workflow. Like imagine like what similar kind of workflows if you convert into the solution is like it definitely saves uh, bit. And coming to high performance, of course, like I mean, as it doesn't need like any resource pinups and any clusters sessions need to be established. Definitely, we seen that in last slide as well, like how the performance is improved. And last but not least, to talk around like open source, it's really helpful on being as open source. Uh, being with the nature of the open source, there are many connectors are available in outside world now. Like already we seen few of them as an example. DuckDB, be it Daft, or and it's really which expands its integration capability, versatility. Okay, so definitely, I mean, we kind of solutionize it, and but when we are productionizing, we also seen some challenges with respect to our using, with respect to our existing use cases, because as we said, like ours is a platform which been from history of years, right, and we have some existing applications, right, and we all need to agree that any problem statement can't be solutioned without any challenges, right? So we also face some challenges. I mean, I just wanted to walk through like what is the existing scenario we have and what kind of challenges we faced, right? So here one of the example we have in our existing use case, right? As we said, like as a platform, right? I mean, we have many applications, many downstream applications as well. And as we said, like Delta Lake is our centralized location, but few of the downstream applications they kind of wanted to see data in our secondary storage as well, right? So at the time, like we kind of built a process that uh, to copy data what all added in what all inserted into Delta Lake to do a deep clone into secondary storage. And we have seen Delta Lake is introduced CDC and CDF concepts. So we have utilized the CDF concept when Delta Lake is introduced, right? And which a process is running always to check what all recent updates on Delta Lake. And in case of many updates, it will go and do deep clone, because if we have a more version of updates, more good operations happen on Delta Lake, we always seen the performance better to do deep clone instead of CDF. I mean, change data feed, right? So you may hit the question, right, basically. So how you are making sure when you're using CDF, like how you are segregating the rest of the records which are not copied to secondary storage. So for that, we are maintaining a metadata, right, which always checks a process which always checks, what is the latest copied version, right, and check again is like what is the available version, right. In case of there is a change in data feed, right, we are copying the data. Otherwise, we skip those data delta tables or data sets, right. So with that, I mean, we have seen, I mean, when we try to migrate this application or use case to the solution what we are talking so about. So at that time, like we have seen Delta RS doesn't have any support to have this have the support on Delta RS natively. But thanks to Sonia, Demi, and Tyler for accepting this, taking this as a prioritized, and helping us fixing this issue, right? And it got released in version 0.19.0, which is really helped to unblock our this process and making sure, again, the data available to end users on a high speed on a secondary storage in secondary storage. Okay, so we have another challenge and use case, which also we took help from Taylor and teams as well. So this is one of the use case, like when multi-cluster concurrent writes into Delta Lake tables, right? Initially, when Delta Lake initially Delta Lake had a limitations for multi-cluster writes, especially to AWS S3. But since last year, when AWS introduced it's a conditional writes that can check existing objects before writing it, right? Since then, like there is a lot of buzz, and we started thinking Tyler and teams, like why can't we introduce this into Delta RS as well, right? I mean, Tyler is kind of able to send us fix in 0.23.0, right, which made us kind of uh, removing this issue, which is multi-cluster concurrent writes, right? And still there is one thing which might be addressing soon, right? I mean, when you're writing data, for example, if you have two processes which are writing to Delta Lake using the um, Delta RS, right? There is no concurrent writes, but when you're using different compute processing tools, for example, one process is writing using Spark, and the other process is writing using Delta Lake, right? So definitely we need to depend on DynamoDB for commit logs to making sure your data is not um, uh, gone, right? So that I think as I know, like there is a dependency in Hadoop like to fix this and taking this forward. But thanks to Taylor and Denny again for always prioritizing and helping us to unblock these use cases. That I will hand over back to Satya.
Cool. Yeah, thank you, Madhu. So as you have seen, different challenges. Each challenge was not a problem with the deltas, but as we evolved with the Delta Lake, new features have come in, and every time we had to go back and update our respective connectors to work with those protocols. And to handle this and to tackle this challenge, again, the same team has introduced a kernel, Delta kernel RS in specific, as well as there is one other kernel on Java as well. So every time there is a new protocol update from the table, they want to manage it centrally at the kernel level, so that whatever the connectors you use, you don't need to worry about reaching out to the team and getting this fixed. You can directly use this kernel and use your connector, update your connector to use the next version, so that you'll be able to read and write from your Delta tables. Maybe Taylor and Danny will add more on this. With that, I want to share some closing thoughts. So you have seen there is no single engine perfect for every data workload. It's all like no one size fits all solution, where especially with data workloads, and it's easy to fall into trap of having Spark as our go-to solution for every problem. And it's not everything is a big data problem. And that's where Rust comes in. Rust has a lot of advantages, as we have seen. You can unlock fantastic benefits because of the memory safety, thread safety, and concurrency, and a whole lot of things, right? These can help you unlock and manage your data in a better way. And also think about the potential savings as well, not just in terms of cost, but also in reducing the complexity across your platform. And yeah, as we move forward, focus truly on your data, select the right tools and engines that fit specifically for your workloads, rather than sticking to the single approach. And that's where you can optimize your processes, drive better outcomes for your organizations. With that, I want to thank everyone, especially the team here. And big thank you to Denny and Taylor, Sonia, for giving us this opportunity to present ourselves here. And big thank you to Sunny, Prashant, and all the S&P leadership team for giving us chance to explore different tools and technologies that we play and keep our platform stable. Yeah, let's open the floor for the questions. But before that, I hope you got the answers to my story before. My house is clean now. There are no sparks. We are safe, completely safe. And if you have more questions, let's reach out. You can reach out to us on the Delta Lake Slack.
Great. So thank you so much for that awesome presentation. Just to open the floor for some questions. So there were some questions that came up during the presentation. So I think the first one that we want to address live is, are there any plans to bring support for column mapping to Delta RS?
Go with Tyler first. Yeah, go with Tyler first. I'll toss him my little bit afterwards, but definitely.
So yes, there are plans. So the Delta kernel Rust project, so that's delta-kernel-rs, has made a lot of improvements in supporting what I would say are much more modern features of the Delta Lake protocol. The next big effort between Robert and Zach and Nick and a few of the other contributors between Delta kernel RS and Delta RS is to bring some of that log replay and processing logic into Delta Rust, because Delta Rust had started long ago and doesn't support those features yet. So we have the early work. We actually just got a pull request this morning or last night from Zach to bring Delta Rust up to 0.10, which was a recent release of Delta kernel S. But deletion vectors and column mapping are kind of next on the list for supporting in Delta Rust, and we're gonna rather than implementing that ourselves, we're going to be pulling kernel underneath and taking a more active role in processing the logs in Delta Rest.
So just to add on to that, just last week we have one of the user who are not able to support their Power BI dashboard because there was a column mapping enabled. They are not able to read it from the Delta RS. So we have a workaround there as well. We have used Delta kernel RS with DuckDB, and DuckDB recently announced experimental support to the kernel. So we were able to get rid of that issue there.
So yeah, it took us a while, but we are working on it. I did drop, I think, in LinkedIn the actual issue, so you can track it. So yes, so just go ahead and track there, and of course, like what Satya, Madhu, and everybody else called out, join us on go.delta.io/Slack. We actually are pretty up to date on all. Try our best to keep everybody up to date. Maybe that's the best way I could phrase that.
Great. Well, moving along to the second question that we got from the audience, does the RS API support the data transformations as well? I see some nodding. I see some thinking.
Well, I think the question is, what does one mean by data transformations, right? And so if you're talking about, for example, like we talked about with CDC, to do inserts, updates, yeah, like this is what this is literally what today's session is about. If we're talking about broader sets of transformations that are like within Spark itself, well, yeah, I mean, that's within Spark, right? And things are being added in to Delta RS, but like there is a difference between the engine and the format. And yes, I knew you were going to chime in, Tyler, so I figured I would set it up so that way you can chime in. So go for it.
So one of the things that ships with Delta Rust is an integration with Apache Data Fusion. And Data Fusion is a fully fledged data processing engine that has an incredible amount of support. And I'm certain that Satya and Madhu are using aspects of Data Fusion in their pipelines as well. But there's basically two ways you can think about Delta Rust. There's like the Delta Lake protocol integration part, which supports operations like compact, optimize, things like that. And then there's integrations with Data Fusion on top of that so that you can use Delta Lake tables directly in Apache Data Fusion. And so in the broader ecosystem, typically when people are doing, building ELT pipelines with Delta Rust or the Delta Lake for Python package, they're using what is provided by Data Fusion, or they're pulling those record batches, as I think Madhu had mentioned, into, a Pandas or a Polars or a Daft, and then working with them.
Yeah, and we also support Pandas and Polars in many of the pipelines, and Delta RS will be behind the scenes.
Yeah. So just to add to exactly what everybody's talking about, like their own slides, I think it was slide 12, the cool animation one with airflow into Delta. Right. It's Polars, Data Fusion, Pandas, all these wonderful systems that are kicking in play, which is great. And so it's not just you can leverage the Rust ecosystem massively for all that. So it's not specifically Delta RS, but the Rust ecosystem overall, absolutely. So yeah.
All right, great. So another question we have is, how are the concurrent writes managed on Azure?
You want that one, or you want me to take that one?
They're not. So Azure Blob Store and most other object stores that are supported don't have or had not had the eventual consistency challenges that AWS S3 has. So there is no additional coordinator required for multi-cluster writes on Azure Blob Store. Even if you're using, Cloudflare's R2 or Minio, if an S3 compatible API, those actually do support a more actually consistent multi-cluster setup. With AWS S3, there's some coordination that is required. They've since introduced that conditional put support. The one thing I do want to caution listeners to is multi-cluster support when you're talking about like Spark or a DBR and Delta Rust. Spark, and Denny, I'm going to tee this back to you. Spark is not yet up to speed on conditional put with AWS, but I'll let you explain what's the what there.
Yeah, I knew you're going to do it to me. All right, so the context that Tyler's coming from is basically S3 was for a while did not have put if absent consistency guarantees. And so this is actually, I want to say mid last year, S3 actually added that in, okay? But the problem is that while you could presumably use the S3 SDK directly, the vast majority of these distributed frameworks like Spark, but this is actually for a lot of distributed frameworks, they're actually not using the S3 SDK directly. What they're doing is they're using the Hadoop SDK itself. And the Hadoop SDK is still referencing the older S3 SDK, which then does not support put of absence. So a lot of the work that's being done actually by the AWS team, so hats off to them on this one, is to go ahead and actually update the Hadoop SDK to support the newer version of the S3 SDK, which does then call out the put of absent transaction guarantees. So there's a slow transition for all of these systems to basically go ahead and start using that. And so once we do that, then boom, we've got something to work with. But right now, a lot of us, like we're talking all the big companies, all the small companies, we're all basically making that slow transition. So in order to be able to make sure your current production systems are still working exactly as they need to work, while also making that transition to now that the S3 includes the put of absent guarantees. So hopefully that didn't bore the living daylights out of you. You're more than welcome to ping me off to the side in the Slack, Delta user Slack, if you really want me to go ahead and go even deeper. But I figured I didn't want everybody to fall asleep now, so I'll stop now.
Cool. All right, so another question that someone asked was, please explain the performance and reliability in terms of concurrent writes when using only the REST API or RS API.
I've done a lot of work on this, so I'll chime in here. So when we're talking about Delta writes or performance of concurrent writes, there's two components of this. There's the data files, which are your Parquet files going into object store, and then there's your transactions. When we're putting Parquet files into object storage, you can do that from as many concurrent processes as you want, as fast as you want. There's no limitations there. When we're talking about actually committing those to the Delta transaction log, Delta, for better or worse, has a monotonically increasing version number. And so every write needs to follow, one has to always be followed by 2, followed by 3, followed by 4. And you can't do sparse writes of version numbers without corrupting the table's consistency. So Carly is going to share a blog post where I dive a little bit more into this particular problem. But generally speaking, if you want to have highly concurrent or high performance writes, you have a couple of options. One, you vertically scale your writers so that you have a writer that's going to take as much data as it can and try to cram as much into one transaction right to the Delta table as possible. Or you segment the two parts of this problem. And that's, I referenced in that blog post a tool that I built called Oxbow, where if you have another system that's just producing Parquet files in S3, in Azure, and other things, you can use bucket notifications to identify when a Parquet file has been added to a table. And then a secondary process can come along. And that secondary process can be a singular process, not a concurrent writer, that just sees the new Parquet files and updates the Delta transaction log. And that's an approach I've seen work really well in production at a number of different organizations, where you have one thing like Kinesis Data Firehose or an external system like Fivetran or whatever, producing heaps and heaps of Parquet data into S3 storage. And then you have a singular process sort of triggering off of that to update the Delta table metadata. When you talk about doing like big giant merges or big streaming processing pipelines, that's where the REST ecosystem probably is not going to be your best bet. That's where you're probably going to want to go back to Apache Spark and use sort of Spark for what it's really powerful at. That's it.
Cool. Another question that we got was, when is liquid clustering coming to Delta RS?
Want me to tackle this
one? How about
you,
Denny?
Yeah, I figured
how about you?
This one. Yes, because the honest answer is that basically it's not a low-hanging fruit. It'll take us a while to actually get that in. So we have other things like deletion vectors that we wanted to get in first. And so that's higher priority. It's not the lack of interest in liquid clustering. It's just that the vast majority of use cases right now that are Delta RS centric involve the smaller set of files. And so because of that, liquid clustering is not as high in priority. Now, saying that, I do expect that to change, by the way. I do expect that over time, people are going to start really giving us grief about liquid clustering. And so this is, by the way, part of the reason why there's this massive focus on us to do this work in Delta kernel RS, mainly because the fact that we can then take advantage of splitting Delta RS from the knowing exactly what the metadata and how the metadata of Delta is actually operating from the actual operations with the files themselves. So hopefully that gives you a little bit of context where the thinking is. Now, of course, if you all say, no, Denny, you're wrong. Liquid clustering is more important. We'd love you to come join us on the Delta user Slack. Also go directly to the issue itself. If you just literally type Delta-RS liquid clustering, I'm pretty sure it's the first one that'll pop up. We'd love you to vote on that one because there have been some discussions on this one. And it's, again, not lack of interest, just a little tougher to get this one out.
It's a challenging one. I actually want to pivot this question to Madhu, because Delta Rust, I think, works really well in that graph that you showed of the like 90% of workloads are like with less than 100 megabytes or something like that. That's where Rust and Python really shine. I'm curious, are y'all using liquid clustering, or do you see use of liquid clustering in the future for ADW?
We are using liquid clustering today. Oh, sorry.
No,
you can answer too. I mean,
yeah.
Okay, yeah, we are using liquid clustering, and yes, but it is only from the Databricks point of view, not from the Delta RS. But
Maybe like we might wanted to vote that question as well, because we have seen good advantages like when we are using the liquid clustering, right?
Yeah, I think I did some benchmarking. It was at least 4x
Nice.
more performant than before liquid clustering.
Yeah. One of the challenges when I've thought about Delta Rust supporting liquid clustering is the environments where I'm typically deploying Delta Rust are those Lambda environments where we're talking about, you've got something running with a gigabyte or 2 gigabytes of memory, and I don't know the phrasing that the protocol uses to define liquid clustering, but like the rebalancing of data doesn't really fit as well in those sort of more confined spaces where I'm putting Delta Rust. And so when we introduce liquid clustering, and I think it's a when, not an if, we're going to have to put some guardrails around it to make sure that users aren't exhausting memory, as an example, or crashing their process when they're trying to perform, liquid clustering writes, because it fits very well in the Spark context because you have your distributed compute environment there. But when you're talking about these very small slices of compute and memory, liquid clustering is a much harder problem to fit into those confined, deployment environments.
All right. Great. So we'll take a couple more questions because I know we're coming up on time. I guess this is a question more for Madhu and Satya, but why was CDC critical to your initial architecture?
I can take it up. Yeah, definitely. It's played a crucial role when we have an initial architecture, because when we started making available data from source to, the centralized location to the secondary storage, like every time we are kind of deep cloning, right? So what does deep cloning does, right? In a secondary storage, it's kind of cleaning up entire data and copying it, right? What if that secondary storage has a downstream applications which always pulling data, right? There will be definitely impact, right? So what all the downstream applications needed is, so what is upcoming data, right? How that you can achieve, basically CDC is doing the trick, right? So it's copying basically what is added in your source, bring that data and copy it to secondary stores, so that your downstream applications is up to date and it's not losing the existing screen or existing logic what it has already pulled up into their existing pipeline or UI. Hope that answers questions.
Yeah, that's I think that's great. I think this is the last question we got from the group, unless anyone has any other questions. But I guess why did you all decide to use Rust in this situation versus some other language or framework? And I guess how did you get to the decision to use Rust?
Okay, maybe I'll take it up. Okay,
No, I
carry on,
mean,
Madhu.
definitely, it's a really good question, and we asked ourselves to this question as well. So we didn't really straightly go and choose delta RS as a solution. We always wanted to drive into multiple look into multiple technologies what are available to
After
solutionize
burning few houses.
problems, right? But yeah, we seen like many advantages. With respect to our problem statement, if we use delta RS, and we know like we are able to drag Tyler like whenever there is a need. So it really helped us. So getting into it, yeah. Satya, you wanted to add anything?
No, actually, I think I have briefly covered in my last slide. Rust has a lot of advantages, and there are challenges with Python as well. And Rust with Python is playing best of both worlds, and it was able to answer our use cases exactly.
Great.
And yes, there is no JVM as well.
Boo, JVM.
You know, JVM still
I'm
does.
teasing.
I mean,
Don't
JVM
forget,
still running a lot, right? Yeah, you
No,
you do
don't
a bunch
forget.
of JVM stuff.
As much as I boo at the JVM, don't forget I am one of the authors of Learning Spark, so I don't think I'm that mean to the JVM. Okay.
Sorry, I forgot to mention one more thing, Denny. Maybe out of context to this, but we have used your Delta Lake Definitive Guide and created a RAG and hosted
Oh,
it.
sweet! That's fun. That's brilliant, dude.
Agentic Denny.
Oh, yeah, there you go. Then it starts swearing and just talking about coffee. That's all it'll do.
I think we got one last question. So this is from a user. I absolutely love polars. When you show it side by side with Daft and DuckDB, are you referring to alternate choices, or do you see each tool has their upsides and therefore can be complementary?
Yeah, so as a platform, we are giving the flexibility for our users so they can decide whichever works for their use case. But at the same time, we are giving some recommendations as well, like which one to use for your use case. You can go ahead and use it, but if it is not meeting our requirements, we'll come back to you and fix it. Maybe I'm giving you a proper answer. Okay, what is the question exactly?
That was kind of along the lines. I think every tool has their different upsides.
Yeah,
If I can throw a little bit on top
and
of
yes,
that.
also there was
go ahead, finish.
Yeah, there was some other benchmarks as well I have run, and I was using DuckDB and Polars and Daft. Sometimes Daft was giving a better answer, whereas DuckDB was playing a good role. And recently with Polars has done a lot of improvements, and it is giving good responses as well. But that's why we don't have, with so many changing things, we are not suggesting anything to start with, and we are giving the flexibility for our users. Sorry, Taylor, go on.
I was going to add one of the things that I think is also a really important part about the architecture that they've adopted for ADW is would you center something around, a big open source standard like Delta Lake, like as a platform provider, you can kind of pick whatever thing you want off the shelf to serve different users' needs. I've seen a lot of use of like Daft and Polars as an example in building like Python-based data pipelines. Whereas I've seen more Python and Polars getting into more some of those data science use cases. And so I think it's really use case dependent, but by building your platforms on top of these like open standards like Delta Lake and some of the stuff that Arrow or Apache Arrow provides gives you a huge amount of flexibility in what your customers might actually need to use on a day-to-day basis. Because a developer or data scientist that chooses Polars today might be choosing Daft next month. And just because it's going to do a better job at this one thing.
I think I seen somewhere like someone was mentioning Gen AI to select the tools and technologies in the pipeline based on the particular use case. It is going to identify the tool that is suitable for this particular workload and change the tool. I don't know how it works, but it's interesting times.
Great. Well, that's it for the Q&A portion of today's webinar. I just wanted to remind everyone before we close, if you want to watch or rewatch today's session, there's going to be a full recording available on the Delta Lake YouTube channel. So if you want to, access this at a later time, maybe you have a colleague who didn't get to sign on today, that will be available for replay. But thank you all so much for your time. Thank you, Satya, Madhu, Tyler, and Denny for joining us. Hopefully you all found this really useful. And again, you can access that replay on the Delta Lake YouTube channel. So